Hi, my dear students. You are welcome to the online learning platform. Today, you are going to learn about plasma arc cutting and welding process. Plasma cutting is a Now you are seeing a diagram that is plasma arc welding with cooling water system. First of all, you should know what is the equipment do you need to do the plasma arc welding. The important equipment is, one is you need a power source. This power source should consist of a open circuit voltage of 80 volts. What is an open circuit voltage? Open circuit voltage is where, suppose if you touch with your bare hands to the electrode, you never get a shock. The reason is, a person will get a shock if this open circuit voltage is above 80 volts. Here the open circuit voltage is maximum 80 volts, and generally the system will use between 40 to 60 volts. So there is no harm of shock. This system uses a current of 50 to 300 amperes. You need a pure DC welding current for this process. You need a welding torch, that is non-consumable tungsten electrode. So in this torch we will have a non-consumable tungsten electrode which will create only arc and heat. Then you need a cooling system, that is water circulating system. Then you need plasma welding torch, and you need plasma gas, that is you are going to use argon gas in this system. Generally this gas is called as shielding gas. There are different types of shielding gases. These gases are argon or mixture of argon, hydrogen, or mixture of argon and helium. There are two modes of operation in plasma arc welding. One is melt-in mode, two is keyhole mode. 1. Melt-in mode. When energy is transferred to welding process from plasma arc, the energy strikes the surface and immediately cause heating. It is due to the combination of conduction of heat in the arc and conversion of kinetic energy. If the rate at which energy is being deposited exceeds the rate at which heat is being conducted away, the temperature will rise and cause melting and produce a fusion weld. This mode of energy deposition and weld production is called the melt-in mode or the conduction mode. Number 2, the keyhole mode process. If the density of the energy coming from the plasma arc is very high, such that the deposition rate exceeds the rate at which it is lost by conduction into the welding process. In this case, the plasma arc can penetrate the molten pool and form a small throughout a hole in the weld pool. It's referred as a keyhole. Moving the welding torch and the associated keyhole will cause the flow of the molten metal surrounding the keyhole to the rare region where it resolidifies to form a weld bead. This is the keyhole mode in plasma arc welding. Keyhole mode produces large penetration than the melt-in mode. Now you are going to see the effects of various factors on weld quality. The instability of the keyhole. It leads weld discontinuities such as excessive penetration and incomplete penetration. The another one is nozzle shape and size. Nozzle constrict the plasma jet stream and focusing the heat on weld process. Another one is tungsten electrode set back. The distance between the end of the electrode and the nozzle exit, and it has a significant effect on weld bead formation and arc penetration. Another one is composition and flow rate of the plasma gas. It has strong effect on the behavior of the weld pool, on the appearance of the weld, on the welding speed, and on the weld. The another one is welding current. Weld joint will be best if a low plasma gas flow rate and a high welding currents are used. Then welding speed. Too high welding speed will result in undercutting and incomplete penetration, while inadequate welding speed leads to excessive penetration. So highest possible welding speed is desirable economically. Another one is distance from the nozzle to the workpiece. Too small height, that is distance, will lead to narrow weld and undercut, while too high, it means large one, will affect the arc penetration and the welding quality. The appropriate distance needed is 3 to 12 millimeter. The minimum is 3 millimeter and the maximum is 12 millimeters. The effect of plasma gas on the weld quality of plasma arc welding is more important than that of shielding gas. Now you are going to see the features of plasma arc welding. Plasma arc welding have very good features. That is, it can protect your electrode well. It can use low ampere welding capability as low as 0.05 amperes. Arc consistency and gentle arc starting. Minimum high frequency noise issues. High frequency only in pilot arc starts, not for each weld. Arc energy density reaches 3 times that of gas tungsten arc welding. Higher weld speeds are possible.